what do you love about your favorite outfit? Do you like its color or how soft it is? Does wearing it make you feel cool or comforted or beautiful? Or do you like what the clothes can do for you, like protect you from rain? The things that we wear and carry every day do so much for us, but they cannot spontaneously become different types of clothing or change their color or adjust to what we do. This is really boring. Wouldn't you like to live in a world where your clothes can do these things? Maybe the shirt that helps you stay cool on a hot day also makes you feel cool. Or the dress that you wear to feel beautiful subtly tailors itself to go from work to an evening event. Or the shirt that you wear to feel comforted gives you a little back rub when you're feeling stressed. My dream as an engineer is to make clothes that can do these things. Our clothes can't do these things yet, but they will in the future, thanks to robotics. Let's look at a robot. Robots like these are big, heavy, and loud. They would be no good for clothes. Lucky for us, there's a new type of robot, a soft robot. These robots have soft bodies and parts. Today, I am thrilled to share with you 3 things that will upgrade your next outfit with the help of soft robotics. You may be wondering, how do we make a soft robot? Could we make it out of fabric? Well, fabric is a fantastic material, but it's hard to shape into the size that we want, and tailoring it to a particular person requires special skill. So how do we get a clothing robot that is custom fit to you and comes in the right shape? We 3D print the fabric itself. This is 3D printed fabric. To make it, my colleagues and I melt plastic into the shape that we want. Think about it a little bit like squeezing toothpaste out of a tube and building it up layer by layer. Only instead of something minty fresh, you end up with a fresh new look. To make this sort of fabric, we build it out of many tiny threads. That way, we can go from a soft and delicate mesh to a tough and robust weave. And with a big enough 3D printer, you could print an entire outfit. My colleagues and I are so excited to see how this material may make it easier for everyone to have their own custom-fit clothing and robots. Wouldn't you want to take your favorite clothing pattern, print it out at home, and get your own robot? This future might be only 3 clicks away. After we have our robot material, our robots need to understand what we want them to do. Let's say I was walking down a street in my hometown, Chicago, and a big gust of wind came. I might squeeze my hands a little tighter to stay warm, and that could tell the robot that I was cold and it needed to make itself thicker, turn on a heater inside the jacket, or even wrap itself more tightly around me. So how do our sensors know that we're cold or anything else that we want them to know? That's where soft sensors come in. This is a soft sensor. It's stretchable and flexible. It's made out of conductive material and rubber, and it can tell our robots things like stretching and bending. This video shows what a sensor output would tell a robot when I were to open and close my hand. So what else can these amazing sensors measure? We can make sensors that tell about twist, stretch, bending, and pressure. These sensors will be the perfect connection between your robot and you, so that it can help you out without you having to say a word. After we have our robot materials and sensors, our robots need to move. Let's say that you wanted to go to the market and bring back 2 bags full of your favorite foods. You could use a clothing robot to transfer the weight of those bags from your hands to your stronger legs, so that when you got home, instead of being exhausted, you'd be ready to cook a delicious meal. If we wanted to try this today, we might need to use electric motors, which are big and stiff. Instead, we can use a new type of air-filled motor. Even though air is so light that we barely think about it, it's very strong. This is an air-filled motor. It's expanded when it's filled with air and shrinks when air is taken from it. It's very light, only 60 grams, and yet it's so strong that I can barely push it together, even trying as hard as I can. Now, I will let air pressure do the hard work for me. When I take air out of this structure, it shrinks, and I can expand it again by pushing air back into it. Using air pressure, we can generate huge forces, even larger than the weight of, let's say, a large melon, just by moving air into and out of these robots. So what will these robots do in our clothing? They might open and close flaps, expand and shrink, and go from stiff to super soft. And we've even used them in my lab to hold up the weight of an entire person. The materials, motors, and sensors that I've shared with you today will bring us so close to my dream of clothing robots. But there's one more thing that we'll need. We'll need ideas from everyone who will use them about what these robots should do. Engineers like me have fantastic imaginations, but we cannot possibly envision all of the interesting, exciting, and fascinating things that these clothing robots will do in the future. I hope you'll share your dream for your next robotic outfit with me. Thank you.